Hi, ladies and gentlemen, this is Mr. Green, and this is another in a series of lessons that's going over sequences. And what we're looking at today are going to be geometric sequences. Geometric sequences. They're slightly different than arithmetic sequences that we covered last time. So, the geometric sequences are ones in which we aren't going to be adding every time, but we're going to be doing some dividing or some multiplying. Depends upon how you look at it. Okay? So let's first of all start off by looking at what is a geometric sequence. A geometric sequence in which we have a consistent ratio is called a geometric sequence. That means that if I look at a current term and the previous term, and I divide the current term by the previous term, I'm going to get a common factor that I can use over and over again, a ratio that I will use over and over again. So if I'm looking at this example right down here, number A, and I look at this one as my current term, my previous one is 78. So it would take 38 divided by 76. And I think you'll see from doing that that you're going to get 1/2 if you reduce that down, right? So that common ratio, that, that ratio between them is going to be 1/2. Okay? And if you do this every single time, divide these two, you get 1/2. Okay, divide these two, you get 1/2. You divide these two, you get 1/2. You divide these two, you get 1/2. Okay, so that's the common ratio between all the terms in the sequence. Okay, let's try this one over here. Okay, so we've got a term of 9, and we're going to divide that by -3. Our common ratio in this situation is a -3. Let's try that on the next one. So if I take 9 times -3, I'd get the -27. If I take the -27 times 3, I get the +81. You can see how it always works out to be that same ratio. And you can see how I'm either multiplying or dividing. To find the ratio, I took this term and took the previous term and divided by it. 9 divided by 3. And then to check and see if it is the right term, I take the ratio, and I'm going to multiply it times this term to find the next term. And then times this one to find the next term. And this one to find the next term. That's how you can use those ratios over and over and over again. Okay? So let's see what we come up with here. It says the formula for the common ratio is a over n divided by a over n to the 1th. And I'm saying a over an divided by an minus 1. You can do some rearranging on this, and what you wind up with is this kind of a formula right here. It says a sub n is equal to the common ratio times a sub n minus 1, the previous term. So if I'm looking at this sequence down here, if I'm trying to find the common term, I'm going to take -16 divided by 8, and I'm going to get a -2. Cool? So my recursive rule here, that's what I'm trying to do here, is going to be a sub n is going to be equal to -2 times a sub n minus 1. Okay? And we're going to use this rule to find the next two terms in the sequence. So my last term is 128. So to find the next term in sequence here, I'm going to take -2 times 128. And that's going to give me a -256. And to find the next term after that, I would take -2 times -256. -2 times -256. And I would get 512, a positive number, 512. Cool? So that's all we're doing there to make certain we understand how to find these sequences. Now, if I want to write this as an iterative rule, okay, different way of looking at it, I want to write it iterative this time, I'm going to say a sub n is going to be equal to a sub 1 times that common ratio raised to the n minus 1 power. And that's the way you can get this as an iterative rule. You can use this iterative rule to find a specific term in a sequence, and you can use the recursive rule to find successive terms in a sequence. Okay, so there's two different ways of using those different things. Okay, I'm looking at this right here, and I could do some fraction math, but I look over here and I see 4 and a 1. All I got to do to find that common ratio is take 4 divided by 1. And so my ratio is going to be 4. Right? So if I take this one, 1/16, or 1/64, and multiply it by 4, I would get 1/16. And if I take 1/16 and multiply it by 4, I'd get 1/4. I take 1/4 and multiply it by 4, I do get 1. So I checked it to make certain it's working. So that is my common ratio. So now, if I want to find a sub n, any n at all I got to do is take that a sub 1, 1 over 64, times 4 raised to the n minus 1 power. So they're wanting me to find the 10th term. So that's going to be 1 over 64 times 4 raised to the 9th power. Now, do I know what 4 to the 9th is off the top of my head? No, but if I use my handy dandy calculator and do 4 to the 9th, I get 262,144. If I divide that by 64, which is what I'm doing there, I'm going to get 4096. So this right here is going to be equal to 4096. Cool? Cool. Well, we'll work more problems in Class Connect, but I just wanted to make certain you saw how this is working. If you have any questions about this, make certain you get in touch with me. Otherwise, I'll see you next time.